Hi guys, Sio speaking again. This is going to be the last time we talk only about one simple or basic function, the exclusive OR, as applied on a programmable controller. So let's see what do we have to do to understand what these buttons are doing right now. Okay then, so in order to understand what to do, I'm going to remind you quickly, very quickly, what is the truth table for exclusive OR. And it's going to be like that. Inputs A and B, the XOR and the XNOR. We can do both in the same table. Remember, the two inputs can only have these values and no other combinations. Remember, the exclusive OR, it does the addition only if the two inputs are different, and if they are not, the output displays a 0. As for the XNOR, it was opposite to it. So far, so good. Now, funny thing, we can restore the equation of the function from the truth table. And there are just a couple of basic rules. For instance, you focus for the exclusive OR only for the situations when the function is 1. So then you can write f from function. Then, for the inputs, if you see the input having the value 1, you write the input like here is a B. If you see the same input as being a 0, you take it as the opposite, or B bar. Similarly for A, here is going to be A bar, here is going to be A. So then you do what? You multiply these two inputs, you also multiply these two inputs, and you add up all the situations when the function is 1. Let's do it. So I'm going to write it here in red. The function equals the second line here, A bar times B, A bar times B, plus, because there is a second time when the function is 1, A times B bar, A times B bar. This is actually the equation you know. You knew it before as being A B bar plus A bar B, but in an addition, if you switch the terms, there is no change. So that's how you can restore the function equation from the truth table. So far, so good. Now, this one, how can this be put on a programmable controller? Take a look. We draw here the two power rails, the positive voltage here, and the ground or the negative voltage here. So then, what do we have? We have an addition. So what is an addition? There are two things in parallel. But what things are in parallel? A product in each of them. So you're going to have something like that. You're going to have, I'm going to draw them like simple switches. This is why it's something similar to what we call a relay ladder diagram. Okay, so we have two branches in parallel. This is going to be A, and this is going to be B bar, and this is going to be A bar and B. So A times B bar plus the other one which is in parallel, A bar times B. And here is the output, which in our situation is equivalent to the exclusive OR. For the output, we're going to actually use at the same time the fan and the motor, so you can see and hear at the same time what happens. Okay? And this should be our exclusive OR as put on a PLC. So relay ladder. Now let's see it at work. Here we are. So now we have the same buttons we used before for previous demos. So here, if I'm going to press this green, you're going to see the light over here saying that the button is pressed. And here I'm going to have the other one. So the two buttons are going to represent A and B. And I put them here on a little program I magnified for you on the screen to just see. You only focus on this part right here, and as you can see, this is going to be A because it's right here. A is right here, take a look. And B is going to be this one. When I'm going to press it, it's going to close B, B bar, A bar. So A plus B bar, A bar plus B, and both are in parallel, okay? So now, let's remove the stop, and now we can start it. As you can see, the two buttons right now are off. None of them is pressed. What the output does, or how the outputs are doing, because this is the fan and the motor, they do nothing, because 0 plus 0, the function refuses to do the addition. If I press this one, now you see, 0 here plus 1 is going to be the output on. The other one, 1 plus 0 is also 1. And if I press both, nothing happens. If you see from time to time a little flash, this is why I left the fan with the light over here, because I wanted to see that. It's not because it's not working, it's because anytime they are both on, the function refuses to do the addition, but in the moment I press or I depress, I'm not always capable to relieve these two buttons or to push them both exactly at the same time simultaneously. So this is the reason why for a very short amount of time the output goes on. It's just to see that you can't be perfect. But as long as the buttons are pressed, the function exclusive OR refuses to do the addition. Only one of them has to be pressed, and now the addition is done. One or the other. One or the other. And of course, with a switch of a button, no big deal, I can convert the whole thing here in the exclusive NOR. The exclusive NOR says if no button is pressed, like right now, or both are pressed, as you can see here on the white lights, the outputs are on. And if I only press one of them, the outputs go off. I release this one, the outputs go on. I press one, the outputs go off. But now you understand why the function exclusive NOR is a bit less used than the other one. Because you press nothing and the outputs are on. It's not always good for safety, okay? So I go back to safety, and then I reconvert it into the exclusive OR. So then, if I press one, the output goes one. If I press the other one, the outputs go one. Okay? When I press both, the outputs stay off. Okay? So, thank you very much, guys, for today. This was the demo about putting the exclusive OR, exclusive NOR on the PLC, and it was just the proof that all the functions, all the logic functions which are actually doing hardware programming, because anytime you want to do a new function, you have to rewire everything, they can be converted into software programming. Like here, we have a program on the screen, and we didn't modify the hardware, the wiring, but we can convert with the use of the buttons, we can convert this in 1, 2, 3 or more functions. Like now we have XOR and XNOR on the same program, okay? So, see you next Tuesday for funnier things. Thank you very much. Bye-bye.